Hi everybody. So today is just a Q&A. If you have any questions from the course that you would like for me to go over, let me know in the chat. I'm just gonna let this run for a bit because I realize we started pretty late and there's no reason to just sit here and stare at a blank screen. So you might as well get to listen to Stardew Valley. But once I see some questions up there, we'll get started. So type away. I think this song's like almost done, so I'm just gonna let it play out, and then we'll get started. There we go. I mean, it's still playing on my side. All right. No. So when you mentioned that question, I was like, wow, did I totally misinterpret this? Or so whenever I get an email from a student, and so this happens all the time because you guys are students. So um, sometimes when you send me a question, what ends up happening is that you send me an email and you get like 95% of what you are saying right, but in there somewhere is like this one like word or comment or something that just it seems out of place. And my first assumption is always, oh, there's a misunderstanding. I should fully explain. And then what ends up happening is I explain things that you already know, but possibly in a way that makes you think, oh, I answered the wrong question. Or I was incorrect or something. And I throw your confidence into doubt. And so this is just an issue about email when like you can't understand my tone. Like it's very easy to tell if I'm talking to you that like, oh, I am not I am not trying to imply something that isn't there. But with email, it's very difficult because email's tone deaf, right? So let's talk about lab number 2. So there's a part where you have. I'm trying to remember the compounds off the top of my head. So there's hexane. That's not a pen. Hold on. There's hexane. And then there's cyclohexene. And toluene. If there's any more, let me know. Oh, those are the 3, right? So cyclohexene would be that. And then toluene. That wasn't very good. Hold on. There you go. 1, 2, 3. We're gonna make toluene happy. There he is. I like to make my benzene ring happy because it looks like a face, right? All right. I mean, the lab is called hydrocarbons, so we're only going to be testing hydrocarbons, right? So, and what we know about hydrocarbons is that they are all C's and H's, and that they're totally. Oops, I was trying to write nonpolar, and so I immediately ignored the part that said non. So we know that these are nonpolar. Anything with just C and H is nonpolar. And so then what we have over here. Let me get a new color because red isn't very appropriate for water. If your water is red, that could be an underlying condition. All right, so here's my test tube. And inside I have water. So this is water. And when I throw these guys in here, whoop, then one of two things will happen. And so I'm going to go case 1 or case 2. And so case 1 is where my hydrocarbon, so this will be my hydrocarbon, goes to the bottom, and here's my H2O. Or, in case number 2, the test tube gets really fat for some reason, because I can't draw a straight line on this to save my life. Oops, that wasn't very good. There you go. I don't have one of those tablets where I can see on the screen what I am drawing. Like, I'm drawing on it basically a dark rectangle, and I'm just trying to do hand-eye coordination, which when you get to become 37 is not as easy as it used to be. Okay, so in one of these circumstances, this happens with water and the hydrocarbon. I guess there could be a case 3 where you make one consistent layer, but we know that that's not going to happen because water's polar, right? So this is going to happen. And the whole reason I'm doing this discussion here is that when you mix 2, oops, let's do this in blue. So when immiscible liquids are mixed, they arrange by density. So, and we'll say lowest on top. So, note that this only works when they are immiscible. Because if they dissolve in each other, then you can't really tell them apart because you get one layer, so you don't know which one is more dense. So depending on your result in the lab, and I know what the answer is. I'm trying not to say what the answer is. You're going to see one of these two situations. And so if you see situation number 1 in the picture, then you know that the hydrocarbons must be more dense. And if you see situation number 2 in the picture, then you know that the hydrocarbons must be less dense. Now, that's for water and hydrocarbons. And note that when I said they arrange by density, what's more dense, etc., only applies when they don't mix together. Now, in the Lagrange case, what Lagrange is it's basically, it might have pentane in here too. Oh, guess who's here? Oh no, she ran away. I scared her. I'm sorry, Maya. I moved too quickly. So what Lagrange is it's basically just random molecules that have between 5 and 8 carbons. She really wants to say hi. Maya, come here. Say hi. Come here, hi. What are you doing? Meow. I think I bonked her with the microphone on accident. She wants to sit in my lap, but I can't do that. And so, because it is just carbon chains with hydrogens on here, so this is also going to be nonpolar. So, when you mix... Oops. When you mix the Lagrange into the tube with hydrocarbons, you just end up with one big layer, right? Or you should anyway. So this is Lagrange and hydrocarbons. The hydrocarbons from above anyway, because they're all hydrocarbons. So if you're asked about the density in this case, which is more dense, the conclusion you should draw is, well, I can't tell here. So if you put Lagrange and your hydrocarbons together and you get one layer, which you should because everything is nonpolar, you can't really answer anything about the density from that. So if you have only one layer, then you don't get to know anything about the density because everything is all mixed together and it's just kind of randomly assorted. So I hope that answers your question more clearly. Okay, cool. If you have multiple layers, then you can learn all sorts of things, but they have to be separated out. And it's also interesting to note that this itself is a mixture. So pentane and hexane and heptane and octane, these all have different densities when pure. But when you mix them all together, the density of this is actually just the average. So, and it's totally going to depend on whether you have more pentane or more octane or more whatever. So finding the density of Lagrange isn't even itself easy to do, because it very much depends on how it was made, basically. So like the manufacturer probably has like a formula where they're like, okay, we're going to put in 20% pentane and 20% hexane, 20% heptane, and then 20% whatever the hell we have left over. And the result of what you get is the density. And then other stuff's going to evaporate because pentane almost boils at room temperature, but octane doesn't. So there will be less pentane over time. So letting a bottle sit there will change its density too. and there's almost nothing you can tell about Lagrange. So Lagrange is just kind of like, we don't give a shit about its physical properties because they change. I think what Lagrange is basically used for in the real world is as a cleaner. So, like, if you get grease on your hands from, like, if you're a mechanic, like, my father did this all the time, is like, because he was mostly a mechanic for our farm that I grew up on. And he would just, his hands would just be covered in grease. And so we literally had a can of gasoline that was just open, and he'd wash his hands in gasoline. And as a kid, I would be like, "Why do you do that? Why not use water?" And he didn't understand chemistry because he didn't go to college and take Chem 131. So he was like, "Well, it works. Water doesn't work." And so I sort of learned when I was a kid that this is true. So that's how you get into chemistry, by the way. Is you have a dad who's a mechanic? I don't know. Sure. All right. Let me know if you have any other questions. I feel like lab number 2 and lab number 3 are the sort of straightforward experiment that almost feels like a waste of time. Like, when I was writing it, I was like, this is a good critical thinking analysis if you guys were the ones to take the pictures. And, like, I feel really, really bad that we don't get to actually do the experiment. Number 3 is going to be exactly the same as number 2. Except there are just more things. You're going to do more tests and have this giant table. And I don't even know what lab number 4 is because I haven't written it yet. I wrote carbohydrates on the syllabus, so I gotta go find out what the carbohydrates lab is. But I am predicting that for the carbohydrates lab, it's going to be test these various sugars, test honey, and you're going to do like Tollin's test and Benedict's test, because those are the common ones. And then there might be some other ones that I'm not familiar with because I don't do those tests. Everybody does Benedict's test and Tollin's test. We're going to talk about those next week, probably. I'm going to teach you how to make a mirror, which is a weird sort of side effect to this class, is you get to learn how commercial mirrors are made, because aldehydes, which are a compound that we're talking about, react with Tollin's reagent to make silver, and you get a mirror as a result. And so literally the observation is, oh, I can see my face in it. If you can see yourself, it's an aldehyde. Like, it's so weird. And then you don't get to do that because of COVID. So it's like, thanks a lot, people who can't wear masks. I wanted to make a mirror. It's okay, it's cold outside. So I'm just sitting here rambling now because I'm trying to fill the dead air. So I'm gonna leave this screen on the screen. I'm just gonna turn the music back on though, and then hit mute so I shut up. But if you have other questions, let me know. So I'll just push this button here. And we'll see what that does. That's a little quiet. Is that going to get louder? Yeah, there we go. Okay. So let me know if you have anything in the chat. And I'll be back when I see something. All right. Last call for questions. I'm gonna let one more song play through. We'll see if we have anything else here. Hi, you're a cat. Yeah, you're a cat. Oh, I didn't hit mute. Crap. All right. It doesn't look like there's any other questions or even comments about Maya, and I apparently did not mute half of my conversation with the cat just a second ago, so apologies for that. But if you have any other questions, feel free to let me know over email. I guess what I'm going to do is go write your quiz for chapter 14, so I will go get started on that. I'll still be around this afternoon because I have nothing to do until 5 other than write quizzes and stuff. So if you send me a quick email or over Discord or your student email, I'll definitely check it out and I'll get back to you. So let's put on the obligatory goodbye music and we'll see you tomorrow for the rest of chapter 14. Have a good day.